All right, happy Wednesday. I just want to take a couple of minutes to go over the notes from Monday. And again, I'm going to do it this way and show you guys. Again, it's all anonymous, so I'm going to worry about who is who. But this first slide, we're talking about a credit card, and they've got a yearly or an annual percentage rate of 24%, but they compound interest monthly. So it's calculated as 2% per month. And that 2% is calculated by doing 24 divided by 12 because it's compounded monthly. So there are 12 months in a year. So 24 divided by 12 gives us that 2%. So we have a card holder makes $1,000 worth of purchases. We want to know which expression would represent the balance on the card after 1 month. And actually, I'm super happy because the majority of us did get the correct answer. It's 1,000 times 1.02 raised to the first power. So remember that 1,000 is representing our initial amount, and that's the $1,000 worth of purchases on the credit card. And then we take my 2% monthly and we change it to a decimal, which is 0.02. But we can't just multiply by 0.02 because that would be exponential decay, and the interest is going to add to our $1,000. So that's why it has to be 1.02. And then the 1 up in the exponent represents the 1 month. So great job to everyone that got that right. On slide 2, it was the exact same scenario, but you needed to write an expression for the balance on the card after 2 months. And if you watched my short 39-second video, which you should be watching, come on guys, it's only 39 seconds. It's not that long. If you watched that, I told you that your answer on this page should look very similar to your answer from the first slide. So I see a lot of really good stuff here. So this 1,000 times 1.02, this time to the second power because it's 2 months. That's awesome. Same thing here. I'm guessing the 0.48 came from doing 0.24 times 2, but remember that 2 should be an exponent. So it does look like a lot of you, this one's missing the 1 out in front. A lot of you did watch the video. This one, not sure what's going on. Make sure we watch the video. So a lot of us did catch on what's going on. So it's that 1,000 times 1.02 to the second power. Same thing for the next couple of slides. So right off the bat, this is good. 1,000 times 1.02 to the 6. Okay. I'm glad that I'm seeing stuff that is similar to the first slide, except for this. We are not adding with exponentials. This is a linear graph. Okay. The 6, remember, gets put in as the exponent, not as the number down below. That stays as the 1.02 representing the 2%. And then here we're talking after 1 year, but we're not going to use 1 because it's compounded monthly. So how many months are in that year? And it's 12. So again, here at the top, we've got 2 perfect answers. So if you need to go back in and change your notes because you were not watching the videos or you got that first question wrong, make sure you're doing that. We do have a test in a week and a half. So it's really important that you understand this stuff first. And if you need to ask questions, do that. You can email myself at wloneman or email Mrs. Rothen at rrothen. Okay, just start typing our names into Gmail and we can help you guys. We can set up the Zoom, a Google Meet. Okay, so same idea, except now we want to write the expression for the balance on the card in dollars after months without payment. Okay, and again, a lot of us did get it. Not as many. It's a little concerning because the first slide, majority of us got it right. And so the only difference from the first slide to here is that we have an m in the exponent because we don't know how many months yet. So this bottom one down here was our correct answer. Okay, so then we want to write an expression for the balance on the card in dollars after years without payment. Okay, so this is a little bit different, but that 1000 and the 1.02 stays the same. So I can eliminate this first choice, eliminate the second choice because those are just 0.02. So I'm down to the third or fourth choice. Okay, but remember that 2% was for compounded monthly. So I can't just take that and raise it to the year power. Instead, it's going to be this bottom answer where I take my percentage, the 1.02, I raise it to the 12 months because there's 12 months in a year and it's compounded monthly, and then I raise that to the t power for years. So it is this bottom answer that's correct. Again, however many months that it's compounded, so 12, it's compounded monthly, so that's why we get that 12 there, and then it's raised to the year power, the t power. Okay, so we've got a new function, f of x equals 15 times 1.07 to the x, models the cost of tuition in thousands of dollars at a local college, x years since 2017. What is the cost of the tuition at the college in 2017? So, since x represents years since 2017, if we're talking about 2017, that's when x would be a 0, and it's talking about our initial amount. So those of us that are talking about it being 15 is correct, and more specifically, it is 15,000. It's not just 15. So we see a lot of that, which is awesome. Some of the numbers, again, I'm not sure where they came from, but it is 15 because that is the number out in front, 15,000. So, yeah, that's the answer for the cost of tuition in 2017. At what annual percentage rate does the tuition grow? So the percentage rate comes from the number inside the parentheses, but remember the 1 is just there because we know it's increasing, and the percent that it's increasing by is the 0.07, which when we change to a percent is 7%. So these top two are awesome. See more 7%. Remember, it's not the whole 1.07. 7%. 7%. Remember, the 15,000 was the starting amount. Okay, so assume that before 2017 the tuition had also been growing at the same rate. What was the tuition in 2007? So my hint was that 2007 is 17 years before 2017. So we substitute negative 17 in for x, and we would use Desmos. So what we can do is flip over to Desmos, and it was 15 times 1.07 raised to the x power. Well, x is years since 2017, and we want 2000, so instead of an x, I would put negative 17. And that's where I'm getting the 4.74, 4.75. And remember, that's in thousands. So those of us that did put 4.75, clearly you did use Desmos, which is awesome. This answer is actually the most correct because it is in thousands. So it'd be 4,750. So this is good, except instead of 2000, it should be 1000. Okay, so some of us did understand it good. Just make sure you are putting it in Desmos like I did here. I replaced the x with negative 17. Okay, flip to this one. So now what was the tuition in 2010? Well, 2010 is 7 years before 2017, so we put in negative 7 for x. So I go back to Desmos. Instead of having negative 17, I'd have negative 7. And that's where the 9.34 comes from, right here. So first couple answers are good, but remember it's in the thousands. So it'd be 9,340. So a lot of us are understanding it. Make sure you are watching the little videos, please. I am not going to go over the final slide other than telling you the answers. So for number 1, if it's compounded annually, the first answer here is awesome. So that is correct. If interest is compounded semi-annually, so every 6 months, that's twice a year. what interest rate would be used for each calculation. I need to take my 3% and divide it by 2. So it's 1.5% when it's every 6 months, because that's 2 times a year. So 3% divided by 2. And then if interest is compounded semi-annually, which expression represents the account balance in T years? So we have to use that 1.5%. So I'm automatically going to eliminate this last choice. And then I have to eliminate the first choice because it is semi-annually, so I can't just raise it to the amount of years. And it's twice a year, so that's why I'm going to choose this second answer right here, because I've got the 1.5% raised to the second power because it's twice a year, and then raise that to the T number of years. Okay, so hopefully that helped. I cannot reiterate enough. I don't put these videos into the Desmos because I enjoy making them. I put them in there so they can be helpful to you. So when I see answers and it's clear that you did not watch the video, because sometimes I give you the answer in the video, that's when I get a little frustrated. So make sure you are watching the video. If you have a comment in progress book that you need to correct your notes, you should have watched this whole video, you're hearing me now, and now you want to send me an email saying you corrected them. So use this. Good luck on your assignment. Like I said, if you have questions, email me or Mrs. Rothen. We want to help you. We just need to make sure that you are helping yourselves by watching the videos. So have a great Wednesday, and I will talk to you guys later.